Now we are starting topic 2.4, terms associated with motion. In this section, we will deal about the terms and technical definitions of the terms which completely describe the motion. First term for motion is called the position. So first of all, you have to know what is position. Basically, position is a place where someone or something is located or has been put. Technically, in physics, position is described the location of a place or a point with respect to some reference point called origin. This reference point can be termed as initial point. Suppose, for example, you want to describe the position of your school from your home. Let your school represented by S and home represented by H. The position of your school from your home will be represented by straight line HS in the direction of H means home to the school S as shown in this figure. The position of your school from your home will be represented by straight line HS in the direction from home to school. Second term associated with the motion of an object is distance and displacement. So we will discuss what is distance and displacement. Distance can be defined as length of a path between two points is called distance between those points. Look at this figure. Here you have 2 points, point B and point A. If your body is moving from point A to point B or from point B to point A along this curved path, then the total covered length between these 2 points, regardless of any specified direction, this is called the distance covered by an object. That's why distance is called scalar quantity, because we are not concerned with the direction of motion. Now, what is displacement? Join point A to point B with straight line. Now I am joining this point A to point B with this straight line. Then this D distance is in particular direction. You can say now your body is moving from point A to point B with the shortest distance in a specified direction. So we can say displacement is the shortest distance between two points which has magnitude and direction. SI units, System International Units of distance and displacement are same. Both quantities are measured in meter. Now we will see difference between distance and displacement. I am also referring exercise question 2.3 part 3, difference between distance and displacement. So here are some differences between distance and displacement. First point, distance is the length of the path, or you can say distance is the total length of path actually traveled by a body in any direction. Means for the distance, direction is not specified. Your body can move in any direction. But for displacement, displacement is the shortest distance, and you know that the straight line distance between two points is always shortest distance. So displacement is the shortest distance between the initial and final position of a body in the direction of initial point to final point. Means here direction is also specified as a initial and a final position. Second point, distance between two points depends upon the path chosen. Your distance depends upon the path of the motion, what path of motion you are choosing. Displacement is measured by the straight path. Here you can't choose, you have to move in a straight line. For a displacement, you have to move in a straight line in particular direction. So displacement is measured by straight path shortest between two points. Distance is a scalar quantity because direction is not concerned. So that's why it is a scalar quantity, means completely described by its magnitude and units. But displacement is a vector quantity. For displacement, you must know the direction of motion as well as the magnitude of distance. Distance is always positive. Yes, distance can't be negative, but displacement may be positive as well as negative. Students, in physics, negative sign shows the direction of motion, or you can say direction of covered path. Displacement, the magnitude of displacement can't be negative. Negative sign shows only reversal of direction. So displacement can be negative, means displacement can be covered in opposite direction to the motion. So that's why we can say due to the direction reversal, we are taking displacement as negative. Moving to discuss third term associated with motion is called speed and velocity, which is very important to know that what is speed and velocity. Before going towards their technical definitions, you have to know that simply speed tells us that how fast your object is moving. So we can define the speed here. The distance covered by an object in unit time is called its speed. You can see here this car has speed of 20 meter per second, means this car is moving with speed of 20 meter per second or covering the 20 meter in 1 second. So you can say speed is the distance traveled per second. Here is the formula for speed, that speed is equal to distance covered divided by time taken. You can also find out the distance from this formula as distance is equal to speed multiplied by time. Means if you know the speed of any particular moving object with concerned time, then you are able to know the value of distance covered by this object. Or we can write this equation in symbolic form as S is equal to Vt. Now moving towards velocity, the rate of displacement of a body is called its velocity. You have to know that the basic difference between speed and velocity is that speed is a scalar quantity and velocity is a vector quantity. You can see here speed is derived from a scalar quantity distance and velocity is derived from a vector quantity displacement. You can see here velocity is distance traveled per second in a specific direction. Means now this car is moving with 20 meter per second to the right. Means now direction is also specified. That's why this term 20 meter per second is now called velocity of that particular moving object. So we can write the formula of velocity as displacement divided by time taken is called the velocity. Velocity is equal to displacement divided by time. Or if you know the velocity of an object with concerned time, then you can get the value of displacement from this equation. SI unit of velocity and speed are same, meter per second. Here we are going to discuss some differences between speed and velocity. I am also referring exercise question 2.3 part 4, difference between speed and velocity. Here, first point of speed, it is the distance covered by body per unit time, or you can say rate of change of distance is called speed. The word rate stands for time. For velocity, it is displacement of body per unit time, or you can say rate of change of displacement is called velocity. Speed is a scalar quantity. You are only concerned with the magnitude of speed. Velocity is a vector quantity. You are concerned with magnitude as well as direction of velocity. Third point, speed gives us idea that how fast object is moving. Velocity gives us idea that how fast object is moving in a particular direction. Change in speed means if you are noticing the change in the value of speed, This is the reflection of change in magnitude of speed. And if you are noticing the change in velocity of a moving object, it reflects either change in magnitude or change in direction or both changes. Here is another important concept of uniform speed and uniform velocity. We will learn here that when we say that object is moving with uniform speed or object is moving with uniform velocity. Here are the definitions of uniform speed and uniform velocity. A body has uniform speed if it covers equal distances in equal interval of time, however short the interval may be. A body has uniform velocity if it covers equal displacement in equal intervals of time, however short the interval may be. The difference between these two definitions is only distance and displacement. Rest of definition is same. So to clear that concept of uniform speed and uniform velocity, look at this figure. Here's a car. This car is start moving from point A at 0 meter, means here is distance is 0 meter. This is the initial point. And after 2 seconds, time 2 seconds, this car is moving through the distance of 4 meter and approaches point A. Again, after 2 seconds, from point A to point B, it covers the distance of 4 meter again and approaches the point B. And on point B, again after 2 seconds, car approaches to point C by covering the distance of 4 meters. So you can see here, in every 2 seconds, body changes its distance or displacement of 4 meters. So body has uniform speed or uniform velocity. For velocity, we will discuss, or you can say we will consider the direction too. Moving towards the example related to topic speed and velocity, here is example 2.2. A sprinter completes its 100-meter race in 12 seconds. Find its average speed. Students, you have to know the formula for average speed is total distance moved divided by total time taken. You have the total time and total distance in the statement of numerical. You can see here 100-meter race means 100 meter is the total distance covered by sprinter. In 12 second means total time is 12 second. So data is total distance is equal to 100 meter and total time taken is 12 second. So average speed will be total distance moved divided by total time taken. So 100 divided by 12 seconds, which gives you 8.33 meter per second. Thus the speed of sprinter is 8.33 meter per second. Example 2.3. A cyclist completes half round of circular track of radius 318 meter in 1.5 minutes. Find its speed and velocity. Look at this figure. Here is semicircular round track on which cyclist moving. This is initial point A and this is final point B. You can see here this is the half circle and radius is 318 meter. So first of all you have to write the data. Radius of circular track is 318 meter and time taken is 1 minute and 30 seconds, mean 1 minute and half minute. So by converting 1 minute into second, you will get 60 seconds and you will add these 60 seconds into these 30 seconds. You will get the total time in SI unit as 90 seconds. So first of all you have to know to calculate the speed you are required distance and to calculate the velocity you are required displacement. So by definition you know that distance is the total length of the path. You know that this is the semicircular path and circumference of circle full. Whenever you want to find out the total full circumference of circle, you are using the formula 2 pi r, means 2 pi multiplied by radius. So for half semicircle you will apply the formula distance covered as pi r, means pi multiplied by the radius. Pi is the constant, its value is 3.14. So I will calculate the distance by using this formula, that 3.14 multiplied by 318 meter, which is 999 meter. So this is the total distance covered by the cyclist. So we can find out the speed here. Speed is described as distance divided by time. Time is here, distance is here. So simply put the value here, you will get the speed as 11.1 meter per second. Now second part of numerical, that you have to find out the velocity of that particular cyclist. Velocity is the displacement divided by time taken, and you know that displacement is the shortest straight line distance between 2 points. You know that here is point A and here is point B. If I will join that point A will with point B, so I will get that this is the diameter of circle and I have value of radius. So I know that diameter is equal to 2 radius, means you will multiply 2 with the radius of the circle, so you will get the diameter, and this diameter is displacement covered by cyclist. So you can get the displacement as 2r, 2 multiplied by the value of radius 318 meter, you will get 636 meter as a displacement. So I can get now velocity here, that velocity is equal to displacement divided by time taken. 636 meter divided by 90 second is equal to 7.07 meter per second. Thus the speed of cyclist is 11.1 meter per second along the track, and its velocity is about 7.1 meter per second along the diameter AB of track. Now we will discuss the term associated to motion, acceleration. This is very important term you have to know. And first question in your mind, that when does a body possesses acceleration? You have to know that what is acceleration and what is the condition for a body to possess acceleration. So the change in velocity, remember that change in velocity of a body causes acceleration in it. So whenever you are noticing the change in velocity, means your body possesses the acceleration. So we can define the acceleration here as, acceleration is defined as the rate of change of velocity of a body. Means whenever your velocity is changing with concerned time, so you can get the value of acceleration. Or change in velocity can be written here as final velocity subtracted from initial velocity. So you can get the change in velocity divided by time taken. Symbolically, I can write here bold A for acceleration is equal to Vf, stand for final velocity, and Vi stand for initial velocity, and T stand for the time taken. So Vf minus Vi divided by time taken is called the acceleration. Here SI unit of acceleration is meter per second square. Acceleration is a vector quantity, as acceleration is derived from velocity. As velocity is a vector quantity, so acceleration will also be a vector quantity, and it can either be positive or negative. So we have to know when you will get the positive acceleration and what are the conditions for negative acceleration. For positive acceleration of a body, if its velocity increases with time, means if you are noticing any moving object with increasing velocity, so for this particular object or a body you will get the positive acceleration. For negative acceleration, if its velocity decreases with time, means you are noticing that velocity is decreasing with time, so you will get the negative acceleration. You can say in daily life example, when you are applying the brakes on a car, your velocity goes on decreasing, then in that case acceleration will be negative. The direction of this acceleration, the direction of the positive acceleration, is the same as motion without change in its direction. Means for positive acceleration, your velocity must be increasing and acceleration has same direction as the direction of motion. For negative acceleration, the direction of negative acceleration is opposite to the direction in which the body is moving. As I have quoted the example earlier, that when you are applying the brakes on the car, you feel the jerk in opposite direction to the motion. You can see here. So now your body movement is in opposite direction to the motion of the car. Positive acceleration is simply called acceleration. But for the negative acceleration, you can use the term deceleration or retardation. Examples for positive acceleration is motion of a car with uniform velocity, and example for negative acceleration, motion of body in opposite direction when brakes applied on moving car. And you can say the ultimate result of negative acceleration is body is attain the position of rest. Here is the concept of uniform acceleration, and this concept is similar as the uniform velocity concept. Here's the definition of uniform acceleration. A body has uniform acceleration if it has equal changes in velocity in equal intervals of time, however short the interval may be. You can see here the car is moving from point A to point C. Initially, the velocity of car is 0, but after 2 seconds, it attains the velocity of 4 meter per second at point A, and after 2 seconds more to approaches the position of point B, it attains the velocity of 8 meter per second. And again, after passing 2 seconds from position B to C, it attains the velocity of 12 meter per second. So you can see here in every 2 seconds, the change in velocity is 4 meter per second. So body has uniform acceleration from point point O to point C. Now we are going to solve some examples related to topic acceleration. Example 2.4, a car starts from rest, its velocity becomes 20 meter per second in 8 seconds. Find its acceleration. Solution, as car starts from rest, so initial velocity will be 0 meter per second. Final velocity is found to be 20 meter per second and time taken is 8 seconds. So acceleration is defined as rate of change of velocity. So we can put the value of final velocity as 20 meter per second, initial velocity at 0 meter per second, and time is 8 seconds. So acceleration is found to be 2.5 meter per second square. Example 2.5, find the retardation produced when a car moving at velocity of 30 meter per second slow down uniformly to 15 meter per second in 5 seconds. Solution, initial velocity is given as vi 30 meter per second, final velocity vf is given 15 meter per second. So change in velocity can be found that final velocity minus initial velocity. As final velocity is 15 meter per second and initial velocity is 30 meter per second. So change in velocity is minus 15 meter per second, minus sign shows decreasing velocity. Time taken is equal to 5 seconds. So we can find out the acceleration by change in velocity divided by time interval. So change in velocity is minus 15 meter per second and time is 5 seconds. So acceleration is found to be minus 3 meter per second square. Since negative acceleration is called as deceleration, thus deceleration of car is 3 meter per second square. So some exercise questions we have to discuss here. Question 2.5, can a body moving with a constant speed have acceleration? Yes, body has acceleration because acceleration is rate of change of velocity, and you know that velocity can be changed by changing the magnitude or by changing the direction or by changing these both. So when body is moving with constant speed, the body can have acceleration if body changes its direction. For example, if body is moving along a circle with constant speed, it will have acceleration due to change of direction at every instant. You can see here in this figure, this ball is moving in circular path at every instant. Its direction of velocity get changes. So velocity changes produces acceleration as direction changes at each point although body is moving with constant speed. Question 2.6. How do riders in Ferris wheel possesses translatory motion but not rotatory motion? Answer is riders moving in a Ferris wheel are also in translational motion. Their motion is in a circle without any rotation. Question 2.11. Why vector quantities cannot be added and subtracted like scalar quantities? Answer is the scalar quantities obey the rules of arithmetic and ordinary algebra because scalar quantities have no direction. They can completely described only by their magnitude. Since vectors have magnitude as well as direction, so vectors obey special rules of vector algebra. Therefore, vectors are added by head to tail rule means vector algebra. Question 2.12. Why vector quantity is important to us in our daily life? Answer is we use vectors in almost every activity of life. A vector is a quantity that has magnitude and direction. Examples of everyday activities that involve vectors include number 1, going towards school. The bus has length of about 300 meter and moving in the direction of your school means direction is concerned and you are talking about the length in specified direction. So it is a vector quantity. Lunch. The displacement from your classroom to the canteen is about 50 meter in the direction of north means you are talking about the displacement, so it is a vector quantity. Third, to describe the car's velocity, you would have to state it as 80 km per hour in south direction.